Streaming or I can.
Okay, we are live.
Okay.
Hello everyone, I am Jiten Thapa and I will be hosting this session of Online Space Workshop 2020. So our second speaker is Mr. Hariram Shrestha, and he is currently doing his master's in space engineering at KyuTech. He is also the member of BIRDS-3 and BIRDS-4 CubeSat Project, and he was also the member of the recently the first satellite that was launched from Nepal, NepalSat-1. So today he will be talking about the testings and verification and design of electrical power subsystem of BIRDS-3 and BIRDS-4 project. So you can ask your questions and queries in the comment section of YouTube or our Facebook page. Now I'd like to hand over the screen to Mr. Shrestha and request him to start the presentation. Thank you.
Okay, thank you, Jitan. Namaste, everyone, and good afternoon. My name is Hariram Shrestha. Now I am from Japan. Currently, I'm doing my master from here. So today I'm going to talking about the design and verification test of electrical power subsystem. So I involved in BIRDS-3, and now currently we are working also in BIRDS-4 CubeSat. So BIRDS-3 is already now in orbit, so BIRDS-4 is ready to go for the orbit, but still not in handover. So my professor is Professor Mangacho. So he is our principal investigator also. And thank you for the Orange Space and EMSAT Nepal to organize this online workshop for today and tomorrow. So today I'm going to discussing about the this topic and like to BIRDS overview too, and to testing requirement and verification to everything. I was a previous presenter also to talk about the BIRDS related many things, but I just to give some summarize about the BIRDS project and the BIRDS project. This is the BIRDS overview. So the BIRDS is like to say joint global multinational BIRDS project. So we can say also BIRDS project. This one is started since 2013 to in KyuTech. Professor Cho started this program in KyuTech with support to Japan government, and also the United Nations outer office, we can say UNASA. So also supporting to this project for as like to a basic space technology initiative fellowship for this project. So in this project through many countries already to deploy the nation first satellite. So in first projects like to in from 2015. So first BIRDS-1 is launched in 2017. According to BIRDS-2 already launched, and the BIRDS-3 is also in orbit. So Japan Japan helped to many countries like to Bhutan, Nepal, Sri Lanka, and also in Ghana, Nigeria, Mongolia. This country already to sign to their nation first satellite. So I'm also the part of the member for Nepal Sat-1 for Nepal first team. So I'm here under the lesson KyuTech. So the main objective of these BIRDS projects to teach the engineering student from the overseas like to nations. So they will build their satellite to gain experience to entire whole development process before to sending the satellite into the space. So now currently we are doing in here. Everybody is to something to learn new thing for space from CubeSat One new project, and now I'm also to currently joining Kyushu project. So this is the reason BIRDS is very important to for our country, because the non-spacefaring countries cannot to send satellite is so much expensive. Also, we don't have also capacity, skill, manpower. So we can build up capacity, so we can transfer our knowledge to new generation when we'll go back to Nepal. So in this case, mission planning to data analysis part, we did everything for BIRDS-3. So now in BIRDS-4 also, we're doing planning, hardware design, spacecraft 3D testing, launching, everything. So this is the right place to connect to international human network to the each other. So we can also develop the ground station and upgrade the ground station for future. So we can develop our some another kind of missions we can fulfill. So this project should be complete in 2 years, entire whole project. So this is a good chance to everyone. This is the flight module of BIRDS-3. So Ravan 1 is the also first satellite for Sri Lanka, similar to Nepali Saturn. Also is the first from Nepal, and you can see is the like student project for KyuTech. So we can say also thanks to the our stakeholders. So from Nepal, Nepal Academy of Science and Technology, the organization who is the stakeholder and who take the whole responsibility from Nepal to send funding and manpower, also the many things. So support to the QTech. So similar to for Ravana Arthur Clark, C. Clark Institute for Modern Technology, and for UGC, like the QTech. Nepal Academy of Science and Technology is the my office where currently I'm working also there. But during this time, I am here for from NAST, like to in my paid leave. So I'll go back to in Nepal, then I'll join also in NAST and start to relate CubeSat program or like a Nanosatellite project in the Nepal. BIRDS-3 project timeline, we can say, if we see here, so MDR is in 2017 20th, similar to preliminary design review also in 24th April 2018. So in this period, Nepal is still not sent to all money during that time. So because Nepal is the first time to experience this kind of issue, so we did many exercises to send money and to start this project. So yeah, finally, but we sent successfully to hold money to government and to the Japan QTech. Then we continuously started our project, Nepal Sat 1 in this BIRDS project. So, so in last year, 17th April, BIRDS-3 has launched from USA, and 17th June 2019, I mistake here, 2019, our satellite is deployed into the orbit. So now it's already 10 months past. So we have many data and also many images. So we currently saving many data from BIRDS-3 and we gain some experience. So this is the one, for example, of camera. So I was already talk about many things. This is just overview of the BIRDS overview. Now, in BIRDS-3 and BIRDS-4, I was involved in actually in EPS subsystem. My part is EPS energy part. I love to work this part. So I am today now I'm going to talk about the EPS subsystem. Basically the objective of the electric power subsystem is to give the power to satellite in orbit continuously to electronics both to sunlight in sunlight time and eclipse time. So basically in this if we fulfill the our objective, so in orbit satellite or CubeSat should be convert the solar energy to electrical energy. It means to generate the power from solar panel in during sunlight time. Similar to the rechargeable battery store the energy as like primary source in eclipse time. So the another main part of the EPS subsystem has to control the charging and discharging the battery for the CubeSat to do whole mission continuously very well. So another line I mentioned in here to monitor the current consumption of the load sent to the OBC from EPS. So recipe can control this part with OCP and protect the current fault situation if occur, though then after then it will be control the whole system by reset, and to again it will be start. So our main basic point is when when we send our satellite or in the orbit before to ISS, so we need to make sure and fully confidently after 30 minutes later only it will be start and to give to command power to communication with ground station. So we can summarize the function of the EPS subsystem power generation, generating the power from 5-unit solar panel, and each constant connected to series, connected in 30% efficiency of triple junction solar cell. So currently in BIRDS-3 and BIRDS-4, we had to use a Azure Space Company solar cell. This one is very good. We also analyze the characterization of the solar cell. I will explain later in test side. So another one is energy storage of the battery. We took nickel metal hydride battery because our this battery is like to BIRDS heritage battery. So we need to confirm, because if we change the battery, we need to make sure to do many tests for like a lithium battery. So it should be team members should be agree to which battery should be used. So we use a nickel metal hydride battery. This one is connected in 3 series to parallel battery, so like 3 in series and 2 is connected to parallel. So we make 3.6 output voltage, nominal voltage, and then 3800 milliampere hour for capacity. The another function is power management and distribution. In our design, we convert the battery voltage into 5 volt one line and 3.32 and on regulables also 2 lines, and to provide the unregulated lines 5+5 voltage and 3.3 to the systems OBC through OBC, and reset package to reset package inside the OBC board. So we said OBC PS through and on and up. This is the block diagram BIRDS-4 because I mentioned in here BIRDS-4 because some part has already upgraded to in BIRDS-4 compared to BIRDS-3. So this one is the currently I mentioned in here because the JAXA safety requirement is the one of the important issue for the system, CubeSat system, because BIRDS-3, BIRDS-4, and many satellites should be go through the ISS and Kibo module, Kibo rover arm to deploy in orbit. So we need to make sure our we need to compile the all system through JAXA. So this block diagram we had changed according to JAXA requirement. In BIRDS-3 and BIRDS-4, all components and in block diagram is similar, but only we change in here about the inhibitors case. Basically, inhibitors has 3 main part like overcharge, over discharge, and external short. So we can decide to 2 part of this inhibitors. In overcharge has only one side, like overcharge from solar generation to the battery part, and over discharge is battery to solar part and battery to load part, and external short means from generation to the load part, both sides. So we can see here in BIRDS-4 has 3 physical switch, 2 is electrical switch, and 1 is a mechanical switch. So deployment, we can see here the deployment switch 1 and deployment switch 2, and the deployment switch 3 is the physical switch, which is to control the line when satellite CubeSat will be go through payload deployed. So we can say GEM payload. I think the name is GEM is small satellite orbital deployer. So we make sure to this system should be working properly. For safety component, we can see here push button switch like to 2. So rail switch like a mechanical switch. So this one is 1. And separation switch we can see here. Separation switch 1, separation switch 2, separation switch 3, and separation switch 4. It means like a MOSFET which are connected in parallelly. And deployment switch is controlled to switch separation switch 1 and separation switch from one place. And this one is controlled to the overcharge and over discharge the part actually. And DAXA to say do not use RBF pin for inhibit. So physically it is existing in this our system, but for inhibit case we make sure that RBF remove before flight pin is not using to inhibits, because we need to say our system is very good from to the electric side. So there are main components. And this is this solar cell site. So these solar cells are connected in series. These solar cells are connected in series. Also, we made this solar panel in our clean room, and we designed this also panel board similar to battery construction is 3 series to parallel. This one is not available to soldering to in KyuTech. So this part we send to in company. So this is the part, and another part we develop in KyuTech. So DC-DC converter is the book boost converter, MPPT type DC-DC converter, which gives constant output voltage always from to output 4.2. If we give below 4.2 or maximum 4.2 input voltage, but it always gives to 4.2 constant output voltage. So these all components and its functions should be doing test. So because we need to give a report to JAXA, they want, and APS is basically to related with the safety purpose also. So we need to make sure about our system is working properly with safety. So in here, this is the distribution of the, sorry. This is the distribution and management EPS design system. So we can see here, BIRDS-3 has only 4 mission, but in BIRDS-4 has more than 8 missions. So we connect the more OCP, and also we make bus line voltage. So DC-DC converter should be connected before to the OCP, and reset peak control the OCP. If the high current should become, the load current should be high, and during that time reset peak should be reset the system and to control the system. So we can see here the on-reg bus 1, on-reg bus 2 is connected to the one for transceiver and another one for the burner circuit. In burner circuit case, the current should not be constant, so we need to make sure it goes to the on-reg voltage. So voltage not be like a constant, or current should not be also constant. So we need to give unregulated voltage similar to transceiver also. So another is 3.3 voltage line and 5 voltage line. So 3.3 has 2 line and 5 voltage is 1 line. The mission should be depend upon the these components, or like MCU, and the data sheet wise we can also make sure to which satellite, which mission payload should be take which bus line. So we discussed before, and we can power calculation, and then we give to the bus line voltage. The reset peg is controlled to the actually OCP line over current protection system by through reset peg. This is the power generation and power budget. Actually, we cannot do real practice in our lab. So we just give simulation tests, and we don't have same time to cannot do to solar generation solar generation in this system. So we need to give external power source so we can generate the power. But this is the MATLAB simulation test. So this one is the BIRDS-3, BIRDS-4 is a similar, exactly similar. So in this case, solar constant alleged take is like 1366.1 watt per meter square. Area of the solar panel should be is required. Efficiency of the solar panels. So then number of exposed panel is 2. So this one is already developed by Kim Sensei in our KyuTech. So actually we always use this kind of simulation test and then we go to real test. So total energy generation per orbit from solar cell is in BIRDS-3 and BIRDS-4 similar to 1120 milliwatt hour energy. So we also minimize our block diode loss and we take only 80% efficiency in this system. So in BIRDS-3, system is working in nominal mode as well as in safe mode, but in BIRDS-4 only what we did only to give nominal mode power budget to working with this system. So this is the power generation and power budget test in for BIRDS-3 and BIRDS-4 is similar. This is the standardized EPS board. This one is in BIRDS-3 and BIRDS-4 is similar because in BIRDS-3 is working properly in the orbit. So BIRDS-4 also following similar board actually. So because of the some kind of reason why we are using same standard board for to BIRDS-4, BIRDS-3 to BIRDS-4. So the development time should be short. Actual development time is we cannot do change anything. So it means it's okay. So no need to support inexperienced member. Everybody has a new, so nobody has a experience. So people can do easily and more effort to mission system. So people can to give more effort to the mission payload, not to the same board again. So this is the reason and reduce the cost also same. So this is the proof already to from BIRDS-3. So people can use BIRDS-4 and BIRDS-5 will be start from next month. So they will also use same similar to the EPS same board. Actually, we can see here, this is the communication, this is the OBC board, onboard computer system, and this is the FAB board. So EPS is connected to the two board, FAB board, and also in OBC. In OBC has reset peak, and in FAB has two other part, FAB peak and other DC-DC converter, diodes, everything should be, MOSFET should be placed in FAB. Only reset peak is in OBC board. So we can say in EPS from here. This is the CubeSat like a standard system. If we separate to all board and subsystem, so we can see here rear axis board to manage text panel board, backplane board to the OBC EPS battery fab is, we can say it's like a EPS part. So communication and mission 2 board. This one is for BIRDS-3. In BIRDS-4 we have more to board for mission. So because in BIRDS-4 has a more reaction wheel system, and also as well as also the many mission. So we add more mission board. So the and we change similar to the system part. Everything is similar, but we just replace the mission board to mission board 1 place only. Everything is similar otherwise. So this is the data flow system. We can say in system, this is the reset peak and fab peak is the important component for the in EPS. So actually, if we see here, main peak, reset peak, and communication peak is to communicate each other properly. So fab peak gives two main peak every 90 seconds to the all data like a battery voltage, temperature sensor, battery voltage sense, battery temperature sensor, battery temperature data, current data, everything housekeeping data should be go from fab peak to main peak. Main peak and the reset peak is controlled to the main reset peak controlled in the main peak as well as like the communication peak. If the reset peak has a control the I already explained about the bus voltage. They have a 3.3 voltage line and also the communication unregulated line. So the control is done through over the overcurrent protection system by reset peak. So if reset peak is controlled properly, so it will be start 30 minutes later after deployed from ISS. So reset peak is the main part is this one, and also control the system every 24 hours. Reset peak will reset the CubeSat system in 24 hours. If there's some kind of happening like to single event latch-ups problem or some kind of overcurrent protection, overcurrent should become. So during that time, reset peak also reset the system in every 1 hour. So this is the programming method. So I like to acknowledge to Adel Posan, so who did the programming. So actually, I did that programming in this BIRDS-4. So I like to acknowledge to him for this part. And we can see here the reset peak data sampling output method. So we can see here the data should be in hex and second, minute, hour, and day. Day 1, day 2, day 3 should be go like similar to, and to other data like similar to voltage, a current, and current 5 volt, unregulated volts like similar to it comes. So regular messaging interface by 2 UART. So UART is communication hardware tool. So it connected to the reset peak to communication as well as like to reset peak to main peak. But reset peak. So this is the fab functioning and data collection, like similar to I already explained. The solar panel voltage, panel current, and temperature. From battery, it comes battery current, battery voltage, and battery temperature. And battery heater should becomes battery heater and control the cases from FAB. So the solar panel temperature as well as like the solar panel voltage should go to the ADC, and the hardware communication should be communicated between the SPI. So battery voltage, current, and temperature is directly go to the FAB peak to main peak every in 90 seconds. And finally come to send to main peak to the communication in ground station. So there are many requirement and verifications will be you need to do because this is the most necessary for JAXA and also for to CubeSat development process. So I took this data from my EPS part. So if you do reset peak and watchdog timer, so OBC reset should be scheduled. So check the reset counter of the reset peak. It means if you have any problem in the system, so it will be reset the CubeSat in every 1 hour. Otherwise, if the system is working is normally, so it means the CubeSat is reset in 24 hours. So, and regularly OBC through the communication we give to the message, so we can get from communication. So we did already this one. This was did by Adalpo. Another one is the solar cell about has a 30% efficiency. So this is the triple junction solar cell from Azure Space. I already talked about this part. So we need to characterization about the current and voltage about the solar cell. This one is a very important part, and because solar cell is also expensive, so we need to to check and verify the with the for data sheet. So the another one is a solar panel surface is necessary for the output power case. So we need to calculate with the data sheet. In this case, we only to measure the area. So this one is already we did because this one is a burst area test. So we were sure for the system. And for power distribution case, 5 volt, 3.3 and on deck voltage, we need to measure, but where we did for many functionality tests by every missions for every system, subsystem. So, and we also measure the OCP test for rush current test as well as, so we verify the for requirements. EPS has connected to solar array and the battery for bus power bus only after separation, means it should be starting from after 30 minutes later when it will become from ISS. So this one is also we did many inhibitor tests in our ground station workshop. So again, and EPS cell provide constant power through the DC-DC to load 3.3, 5 volt. Inside there are load, DC-DC is the main part. So we did many tests, many times to test in DC-DC. So it makes sure the after DC-DC it comes like a constant output voltage, and similar to the solar array voltage from solar panel to by do reset peak and also fab peak. Now I'm going to showing some test result in BIRDS-3, like similar to BIRDS-4 also. So this is the Azure Space triple junction solar cell. It has a 30% efficiency. So in the test time, so the output voltage like a VOCI is 5.13, and the ISC has 0.33. During this test, we make sure the solar simulator result calibrate at 10 millivolt because we have sun simulator. So we did this test inside the clean room. So we gave a load current to accordingly to increase 50 milliampere, and then we can see the major output voltage. Finally, what happened when the voltage should be go below 4.05, 3.03, so it will be stop to, so like it means the short current is like to almost zero, very minimum. So we can say this solar cell is okay. This result is connected in two solar cells in series. Then finally we can see is the panel result. Otherwise, the only single cell has the 2.7 volt only.
I found one option, Charlie's Phoenix on West Camelback Road.
And this is the cell screening system. Cell screening means like a battery screening system. So we did this one is from charger discharger system we developed in KyuTech. So this is our methodology to make sure the battery should be to make sure to cell matching is a very important part. So how do we did? We did many times of cell screening. Minimum 3 is necessary. So we did 4 or 5 times, but 3 times is most necessary. So vacuum test and vibration should be come in between the in testing time. So what we did, the physical inspection is the also necessary, but we need to also make weight loss, length, dimension, physical measurement, and the charging and discharging. So it means impedance checking method. After that, we should do in vacuum test in low pressure, inside the vacuum chamber. After that, again, we should measure again same process, and vibration test should be necessary for the chemical inside the battery chemical should be damaged or not the battery, like in during launch time. So we need to make sure this is the part. And finally, we are going to measure the all physical and the necessary inspection and also charge discharge system. So finally, we will do cell matching process. So main objective of this system is to find out the electrochemical characteristics and find defect of the battery, so we can choose the good battery only for the system. And finally, we need to send the company part to connect the battery 3 series and 2 parallel. This is the battery screening process system in KyuTech. We developed this system. So actually, one time we did 4 battery. So regarding this system, pre-discharge, first is pre-discharge, then charge, post-charge, again discharge. So it takes minimum 18 hours for battery in for one time. So we can see this is the, for example, of the battery cell screening. So I'm talking about the battery part because this one is very important for the safety issue. Yes, and also in ISS, this one is very important. We need to give battery verification report. Otherwise, our satellites will not be accepted. So I did only 3 times result in here. This one is the nickel metal battery result. So similar to, we can say the battery is very good because the charge characteristics and to discharge characteristics, you can see here the battery has almost 2000 milliampere hour capacity, and the discharge voltage is 1000 millivolt, and the nominal voltage should be 1.32, maximum it goes to 1.7. And the nature of the charge characteristic of the nickel metal battery has to, at the end of time, it trickle voltage is a 10 millivolt. So it should be then after go to the down. So this one is the actual result, satisfied result. So after that, we need to select the battery from kind of test after environmental tests. It means to charge DC resistance, discharge DC resistance, charging capacity, and the discharging capacity. In here, I forgot to mention of the unit. So DC discharge resistance and discharge charge DC resistance will be in milliohm. So it means first cycle to the third cycle. I mentioned in here for 3 battery case. So finally, we can choose for in discharge DC resistance battery and capacity and mass. After that, to the physical inspection is the important part of the choosing the battery cell matching, because in our case, battery is 3 series, 2 parallel. If we need to use a battery is a very similar DC resistance or DC impedance. So in series case, the battery should not be to balance each other. So the battery should be like burn or like to very produce heat. So it will not be good for the CubeSat purpose. So we make sure about the after environment test, we need to choose carefully about the very close DC resistance value for this battery construction. DC-DC test is also important. I talked before about this part. How do I did? It takes almost 1 hour to 2 hours. Because we need to give um, low voltage to maximum voltage. When the battery is full, so the current goes to constant current to constant voltage method. So we need to take only electronic load current and FAB board and also the power source method. This one is I did before to engineering model test. So it means to we can make sure solar cell to battery should be overcharged or not, we can say from here. So in-EV test is a very important. I explained before about the why we need to deploy all 3 deployments which is required because we need to make sure and this is working or not, because in push button switch is has 2, rail switch has 1. So the MOSFET should be working properly. Otherwise, we cannot to send the CubeSat to the system. So in EPS part, the one of the most important part is in EV test. Overcharge, over discharge, and external short. In EV test, there are 3 deployment switch. So only I present here 1 deployment switch test result. So another 2 results like similar, so I get. So we also check from port. the board model. So yeah, the result was good for BIRDS-3 and similar to BIRDS-4. This is the OCP sensor test. Because we have there are 3.3 volt line, 5.5 volt line on regulated voltage line. So we need to make sure the OCP sensor is working or not properly, and it will be triggering or not. Yeah, all for burner circuit case, it has a 4 ampere OCP line, and other has 2 ampere only, but every line should be work properly. In burner circuit, we can see in here only unregulated one. So the expected ampere is 4. Yeah, OCP is triggering after 3.8. So it means 95% is a success. So similar to other power line also is successfully to do work. This is my last slide. So I like to acknowledge and thank you to everyone who support our BIRDS-3 and BIRDS-4 team member and host country. Thank you. Thank you, Saurabh.
Okay, that was a great presentation. We learned a lot, and I hope the audience learned a lot as well. So we have a couple of questions. So Ricardo has asked, please tell us about the test that the EPS has to pass. Which standard do you use for environmental test? So you can see the question in the Zoom group chat as well.
For EPS test is for environmental test is basically TBT test also. One is a vibration test, another one is vacuum test. Should be done necessarily in the ground test.
Which standard do you use for environmental test?
In vacuum test case, I gave a very low pressure. Pressure is 1 into 10 to the power minus 3 Pascal only for 3 hours only. In TBT case, we did many times like similar to RAM cycle. Okay, actually in the RAM cycle, during that time we put not only battery, not only EPS, we gave a whole EPS, whole satellite system. So during that time, our one battery has also damaged. So it goes to minus 20 degree to plus 55 degree temperature. During that time, we measure. And for RAM cycle, it takes around 8 hours per cycle, per cycle, I think. In TBT time, not only every team member has there. So we measure not only for EPS. So yeah, EPS also included that part. And another is a vibration test. In vibration test case, I'm not sure because the Japanese Japanese person helped me because everything in the Japanese version. So this part I don't know actually. I'll explain later.
Okay, so in slide 19, you showed the charging and discharging of the batteries that you use. So what type of setup did you use to measure that?
This one?
Yeah, no, next the curve, the charging and discharging curve.
Okay.
I think
this
that's
one?
the next page. Yeah.
This one?
Yeah.
This is the result I got from this this charging discharging system. Okay. Actually, this system we developed without electronic load. This system has everything. In previous satellite use electronics load actually, so we can get this system and DAC method. But now we develop this system without necessary DAC as well as electronic load, because everything resistance and many things load part is also included in cell switcher part.
So you just put all the batteries there, and it
Yes.
automatically measures the current, voltage, and when the voltage and current, when the battery is fully charged, it discharges automatically.
Yeah, we can get a result from LabVIEW programming method in LabVIEW.
Oh. So another question is, you use nickel metal hydride battery. So what differences are there in charging a nickel metal hydride battery and a lithium ion battery?
Because lithium ion battery is a little bit risky compared to nickel metal battery. So in EPS board, we should make sure about to use more safety precaution for lithium-ion battery. In the Kitsune, yeah, we are using lithium-ion battery, but in BIRDS-3 and BIRDS-4, we use in-loop battery, in-loop nickel metal hydride battery, because in lithium-ion battery is a more powerful battery compared to high energy density, and also the volumetric energy density, because we can get in the market 1.2 volt nominal voltage of nickel metal hydride battery, but in lithium case only minimum is 3.7 volt we can get. And the size also the important part, and also the weight. If we put this battery, it takes more place as well. Also the height, the main thing is the risky for the system, because if you are not putting any precaution system, so you cannot use a lithium-ion battery. So in EPS of BIRDS-3 and BIRDS has not more so precaution for the lithium-ion, so we use actually lithium nickel metal hydride battery. And another reason one is in BIRDS-2, they use nickel metal hydride battery. It means it work properly. So BIRDS-3 also to take this kind of heritage battery. So BIRDS-4 also the same, because the Paraguay is the first country to, they are going to deploy the first satellite, okay? And team member also, they make sure which batteries will be do before to starting the project. So this is the also reason, kind of management reason.
So what about the cell balancing, since you use 3s2p configuration in the battery?
Yes.
So, is it similar to lithium ion or different?
If we use lithium ion battery, we don't need to more battery, like in our nickel metal battery has, we put 6 battery, okay, 3 series to parallel. But if we use the lithium ion battery, only 2 is enough. But cell matching is important, yes. Cell matching is important. So DC impedance is a very important part. So this all process will be to take a result for DC impedance. So we need to make sure the cell balancing. If you are connecting a series 3 cell, so you should make like, for example, if you have a 65 milliohm or 70 milliohm battery, it is not good. If you can get like a 65.1 is okay, because all battery are not exactly similar, but 65.1, 65.2 is okay. So we need to make sure that part. Otherwise, the more differences should not be good for the connection in series. In parallel is okay, no problem. But in series case, it will be create resistance high. So the output should be not come out properly, and the systems will be heated.
So we have a question from Sonam Sakya. So have you used any model checking tool for design and verification of the power system for nanosatellite?
Yes, I did others also, like like solar cell attach method process. I did not include here. I think I forgot. So yeah, other also we did diode test also. And also we mentioned about the I mentioned in inhibit case double insulator for bicaptain, but later professor told me to use RTB, because the RTB is also good for to the system. So I mentioned later RTB, but this RTB is not too completely done, so I didn't mention here. After this corona issue, so then I will go and restart again. So I didn't mention here. Yeah, I think I did. I mentioned in here overall that kind of things. Only 3 or 4 test method is not included in here actually.
Okay. So another question, I think from Sisir, Sisir Panta. The question is, what has been the temperature that you have been able to measure on the solar panels in orbit? And what has been the percent of variation of efficiency of the cells in flight due to the temperature? So this question is from Sol de la Rosa.
I think I will send it later, because I don't know exactly the orbit data result of BIRDS-3. We have a lot of data. I will send later. But now the orbit result, I don't know actually. I didn't mention in here. So can I send a letter? Can you send me this question? So I'll check first orbit result and then I'll send.
Yeah, we'll send his profile. So another question from CC is while simulating input power to the system, did you consider infrared radiation and albedo radiation in your calculations? And what effect do these radiations have in the real input power generation?
Radiation part, I did not do this part. I don't know actually.
Okay.
So maybe you can take help from your friend, and then you can send the answer later so that we can.
Okay, I can say about the MOSFET case in a radiation test, but battery we never did this. So
Okay.
I will send the result about the MOSFET so he can understand about the radiation part also.
Okay.
Because in KyuTech we don't have this test facility, so yeah, this is the reason.
Maybe he's talking about the like while you're while you're radiating your solar cell with the solar simulator or with the source. So like, are you also
This
being
one is
able to,
I understood.
like, are you
Because
also considering the factor of infrared
yeah.
radiation while you're sourcing your energy to your solar cell?
you
I
mean
think
that kind of
that's
factor?
what he's
Yeah.
he wants to say.
Or maybe he's asking about the sun simulator, whether it
Ah,
considers albedo radiation.
yeah, in lab 1000, I think 1000 is the radiation standard format. 1000. I exactly not sure, but okay, I'll see first and then tell him about the how much. But okay, I can say to him.
So another question is, what parameters do you consider while selecting a blocking or bypass diode for the solar?
Yeah, one of the reason is we need to do very fast, okay, and it's like a birds heritage. So birds 2, birds 1, birds 3 is did already. They already selected many components, so we don't need to say different reasons. So we just select or we just to order these systems. And another reason is also we need to make sure about the temperature of the system components. We should make inside the constant temperature. So otherwise the system will not be working properly. So BIRDS heritage members already to define many times to this system is okay. So we just follow this in this part. Otherwise, if you don't have any kind of components like to previous satellite heritage system, so you can buy from any company or you just test and you can do later.
So I missed one from the battery side. So do you also have the temperature control in the battery? Like if the temperature is lower, then do not charge or something like that?
In system or inside the battery?
Is it actively
In your
controlled or is it
system?
passively controlled?
Yeah.
The temperature control mechanism for the battery.
It's like yeah, how to say, it's like we have a battery heater, so battery temperature sensor also included inside the battery box. So it's like a passive, I think, not actively, not this one is a passive type.
So okay. So and yeah, can we talk more about the sun simulator? Like we don't have access to it, so can we build it here in Nepal or something like that?
Yeah, you can see in NAST we have also sun simulator. You can go and see if you want to see. In NAST has a big one. This one is a service oriented type. Uh, So if you want to learn exactly similar, so we established one sun simulator inside the lab, but this one is handled by REDS. Actually, you know REDS, the red house inside the NAST building, opposite side of building. So you can also talk about the Dr. Shrestha, so you can go and see, and no problem. This one is a big compared to lab some simulator.
So now this is kind of a general question. Like you worked at NAST, I think, for a couple of years, many years, and you went to Japan and worked or studied there. So what are the differences did you find working in Nepal and in Japan?
It's very different, you know, it's very different. When I was in Nepal, I just failed, just when you gave 3 hours exam, okay, it's okay. And you should pass in, and it's okay. But in Japan, you don't need to give, in bachelor degree, you should give exam, but yeah, I see in here, fourth year student from, there are also involved in our BIRDS-3, BIRDS-4 and KyuTech project. It means very different because they want to, they already to export in BIRDS in, I think in bachelor fourth year. Even when I was in Nepal, I don't know what is the components, even I don't know, you know. You guys also did very well, you know, after the, I think some university is doing well, but many engineering college is still not to follow the proper like teaching style and practical style, because only we need to focus our 3 hours exam, how do we get pass, only these things. But when I came here, yeah, exactly differently, uh, different society, like different societies people are in here, like different countries people are in here. So they teach you, okay, if you don't have any idea, it's okay, but you should learn very well. So if you don't have any idea, so you can get knowledge to other people, you can do any kind of you can use any kind of facility, you can do any kind of research. You don't need to worry about the also money. But in Nepal we have a problem because the money also issue. But in engineering campus even they don't know how to use oscilloscope and multimeter, that kind of things. So this is the issue, what I realize in here. Yeah, I feel also very hard as the beginning days, but now I know what I'm doing and how to take the responsibility and how to find out the issue from issue to result. Yeah, that kind of things. I think I can now. Otherwise, in 1 year and 3 months, I feel very bad in here. Why I came here?
So is there any plans that you made after you come back to Nepal? Like this is the thing that I want to do, or this will.
Yes, yeah. Actually, I talk about many times to our Dr. Ravindra Dhakal sir. So he's our faculty chief. So he's taking an initiation about the establish about the space research, space technology research center actually in NAS. So Srin Babu sir, vice chancellor, is also interested to develop one research center in like a only like not a whole space related, I suppose to space technology type. So we can build up the new CubeSat, or we can also do give a training, that kind of things, or we can to help to the new generation people in from NAST. Yeah, so and this year, last year we did one outreach program. So this year we have more than 7 to 8 outreach program. And also we need to establish the small like center now. But yeah, I will back to NAS, then I will start to continue this center. I hope government will help us so I can to
So I don't think
Yeah,
support
we
the
have.
new
that's really,
generation.
really necessary in our case.
Yes, yes.
Yeah.
So you guys
So
are
yeah,
doing
you need
very
to.
well, okay? Because nowadays, yeah, in Nepal, it's very hard. We don't have a proper management system, like to also budgeting system management, and how to say, like if you want to buy some kind of components or like some things, so you should
Yeah.
go very long management system way, okay? In here, professor is
Yeah.
give to approve, is okay, final. Your components will be coming 3 or 4 days later. In Nepal, it takes 1 year or three
Yeah.
months.
Yeah.
This is
So
the problem.
the government process is even longer
Yeah, yeah,
than
this is
that.
the very long issue.
Yeah. So yeah, I think the questions. Do you have any questions, Saurabh? Any more
Yeah,
questions?
we have one more question from the audience itself. So it's from Sisri Panta. So he said that the question is, you said that the DC to DC MPPT converter to be buck boost converter. So why did you choose buck boost converter over boost converter? Over boost converter while charging the battery, will it be necessary to step down the voltage? So like why did you choose buck boost converter over the boost converter? So that's the main core question he wants to ask about.
Actually, we need to get output is 4.2. Okay, sometimes the input voltage will be high, so sometimes will be low, 4.2. So the DC-DC always to gives 4.2. So this one is already designed by our professor because we did not design this part. So we just follow the and test the result. It is working properly or not in our case. So BIRDS-3, before to BIRDS-3, it's already designed. So if you have, what I did, I measure only DC-DC, constant output is coming or not in my case. But the main issue is, professor used this one for, the output should become continuously the same output voltage. So I think this is the reason.
Okay. So I
So
think
yeah.
that's all about the question from the audience. So
is there anything that you'd like to add or say?
For my side?
yeah.
Okay, I'd like to thank you to everyone like Rakesh, so as well as to Jiten and Saurabh. You guys are doing very well, and you guys are the renowned person in Nepal. Yeah, because I always support you because I feel in here what kind of seasons will be happen if you don't have materials and you don't have any expertise in there. You do from very well in from there. Yeah. So I would like to support if you have any request for me. So okay, in future also I will help you continuously. And let's support to the new generation. So if they want to do something like in CubeSat case or as well as to robotics case or other parts, what I know, I can help to like not if even if I cannot do it from here, from my side, I will take help to professor as well as other friends and then support from here. So I think we can to develop the some kind of system in Nepal also. So new people can do new things. So we can change the something in Nepal, like in technical field. And thank you so much for to give me chance. I'm at Nepal and Orient Space, and and thank you to everyone like who watched our video and to our experience. Thank you so much.
So yeah, we'd like to thank you very much for giving your valuable time. I think it's more than an hour. So we hope to collaborate or work with you sometime again, and maybe we can do another session as well, if
Okay,
possible.
sure. Yeah. Okay.
Yeah.
No problem. We can do later.
So yeah, I think it's over. Yeah, we'd like to thank. Now I'll stop the